Hey, it's time for some chemistry. Here we go. Today we're talking about gas laws. Specifically, we're going to talk about pressure, how to measure pressure, and then we're going to get into Boyles Law, which I'm trying to go quick on these. I'm not going to do a bunch of fluff this year because of the nature of the year. Let's just get started here. Okay, now we're going to start off. Remember, we're following our notes here. So I'm going to follow these notes, and I have some pictures that I have on an old PowerPoint that I'm going to show you at the same time. So I thought that would be more enjoyable than just having me describe a barometer with my fingers and hands. So let's look at these pictures here. Where is it at? It's right here. And that's not the barometer, though. Here's some classic barometer pictures that we have. This right here is the one we're going to talk about. This, of course, is the barometer that you would see in your house or in the school hanging on the wall. This one right here has mercury exposed to the atmosphere, which is dangerous for people because mercury in vapor form is dangerous. Here has no mercury, just the spring to record the pressure. So let's talk about this barometer, and we won't talk about this barometer today. But again, here we go. So let me change. Here's a picture I drew of a barometer back in the old days, right? I did this with my Apple Works. And the barometer is a giant glass tube. And this glass tube is like a test tube. So think of it as a giant test tube. And remember our water displacement experiment where I put my thumb over the water and we turned it over and then we put the hydrogen in it. And before we put the hydrogen in it, the water stayed up in the tube. As long as the mouth of the test tube was underwater, water stayed in that tube. So what kept the water in the tube? Air pressure, right? Air pressure pushing down on the water held it up in the tube. How much water could that hold up? A lot. I forget the exact height. I think 28 feet. If you were going to do that, you could have a tube 28 feet high before that water would start to push down, right? So that's pretty high. Well, for the barometer that we use mercury. Why do we use mercury? I think it's 14 times denser, 13, 14, 15 times denser than water. So it's a lot heavier, right? So if it's a lot heavier, a lot denser, the tube doesn't have to be as high. So a guy named Evangelista Torricelli. Hey, look at that. The upside down mustache, the soul patch. You know, he's got the start of a pretty cool hairdo here. Fur jacket. Pretty cool guy. He was actually one of Galileo's assistants. And then he went on his own, of course. And then he invented this air pressure measuring device, the barometer. And, of course, he used mercury. That's what that says. So let's look at this picture again. So the way this works is you take a giant test tube of mercury, you flip it upside down with your thumb over it, you stick your other finger under mercury, and then because the mercury is so dense and it's pressing down, the force pressing down is greater than the atmosphere pressure pushing it back up the tube because air pressure is pushing in all directions, right? The mercury can't stay on the top of the tube, right? So the force of gravity pulling it down is going to be in equilibrium. It's going to be equal and opposite to the force of the atmospheric pressure pushing it back up. And what that is actually doing is then measuring the force or the pressure. Pressure is just force per area. So it's measuring the pressure or the force per area of the atmosphere. Okay, now that's what they did. That's it, right? And so that's how you make a barometer. Now, they went on and discovered some stuff with this. As the weather changed, the height of that mercury column changed, right? And so they could use it to predict the weather, which is It's amazing, right? And then also, they said, hey, what's in the top of this tube? Nothing. And so they actually also came up with the concept of the vacuum at the same time, where there's nothing in that tube. There's nothing there, right? And so there's not an air bubble here. It's just there's no air. They didn't know for sure if there could be a place where you could have nothing, and there it is. Okay. Anyway. So let's go look at our notes. All right, so Evangelista Torricelli, right on here, right, the person who invented the barometer. Okay, got that? The barometer, device used to measure air pressure. Manometer. Okay, the manometer is just a device that uses to measure the pressure of gases in a lab. This is where my drawing skills, I gave up on this and I took them off the thing. There's one of this, I have a picture of it right here, right? So it's the same kind of idea. You have a sample of gas, it's pressing up the gas, it's producing gas in here, and it's pushing up a device with mercury in it, similar to the barometer. Okay, and that's the manometer. Okay, now, units. We need to have units to measure pressure. So that's what we'll talk about now, how to measure pressure. How about if I go here and I bring this down a little bit? Okay, now the first unit we use, or we talk about, it's probably the most common one we use, is millimeters of mercury. And what millimeters of mercury is talking about, of course, is the height of that barometer mercury. So say the mercury in the container goes from, let's color that. You're like, oh yeah, I see why you did regular pictures, Mr. Arnold, instead of trying to draw your own today, right? So if we measured this height right here of the mercury in the barometer, that's mmHg, millimeters of mercury, that would measure the atmospheric pressure. Okay, now, if you're a famous scientist and you invent a barometer, they better name a unit after you. That's just a cool thing to do. Well, look at the next unit, torr. So torr and millimeters of mercury are the same thing. Right? So we use the term torr or millimeters of mercury. They're interchangeable. They mean exactly the same thing. Now, there's very small units. They're very small. And so we have a bigger unit that we like to use, one that's more practical, that you can just say to anybody, hey, what's the pressure, blah, 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 or in general, right? And that's called atmospheres. And the label for atmospheres is ATM. Right? So that's not where you get your money. This is atmosphere. Now, 1 atmosphere is actually the pressure at sea level of the air. The average pressure, I mean, because it changes, right? But the average pressure of sea level at sea level. As you go higher elevation, there's less air above you, so the pressure would be lower. So in Upper Sandusky, it would be a little bit lower than it would be at the sea level. If you go down to Death Valley, somewhere below sea level, it would be higher, right? And so air pressure is different all over the earth depending on your elevation and also the weather, right? So 1 atmosphere. So for scientific reasons, 1 atmosphere, the unit, is equal to 760 millimeters of mercury, which is also equal to 760 torr. Okay? Now, what can we do with those? We can do some factor label stuff, right? We can use those as factor label units. Right. There are some other units that they use. There's pascals And we're not going to use pascals, and since it's a short year here, or since it's a, lockdown stuff, we're just not going to use it. And there's also PSI, which is pounds per square inch, which is the English system, right? This is what you use to fill your car tires up and stuff like that. It's about 15 pounds per square inch, but we're not going to use that in our calculations. Okay, we probably should put a 760 here. Okay, so that's how we measure pressure. Air pressure. If you want to measure pressure in a lab, you'd use that manometer. Well, a guy measuring pressure in a lab using a manometer named Robert Boyle did a little variation of this. He took, didn't want to do that. He took a glass tube like the shape of a J. If you remember that manometer picture, it was like a shape of a J. And it looks like an upside down candy cane or a cane, whatever, right? And he put some mercury in here. And he had a gas. I don't know if you can see that or not. Let's go to some darker mercury. There we go. And I don't know if he had what exactly he was doing. I don't know if he was doing this experiment on purpose or if it was an accident. I don't know. All right. But he had some air here in the end. Not a vacuum this time. He had a little bit of air in there. And then he had some mercury up this above it, right? So the pressure would be the mercury above that line over there, right? So let me scoot over here closer so we can see it, right? So from here to here, that distance between there, that would be the millimeters of mercury pressure on that little bit of air, that gas over there. Well, guess what he did? He put more mercury in it. I'm going to try to make it look lighter. I'll make it like a light blue. He put more mercury in the tube. And guess what happened to the bubble of air on the other side? It got smaller. That's the experiment, okay? But of course he's measuring this. And what happened was this. If he doubled the amount of mercury, that would be doubling the pressure. The volume was cut in half. All right? And he came up with this equation. And it's called Boyles Law, but it's P1V1 equals P2V2. That's the pressure and the volume in the first case. So that would be the gray. The pressure of the mercury on that gas bubble and the volume of that gas bubble in the first case is equal to the new pressure times the new volume in the second case. All right? And so, in other words, easy numbers. Let's say this is 1. Let's do it without a thing. This is 1, this is 2. If you increase the pressure to 2, what happens to the volume? It has to go to 1, right? We're multiplying these. So in other words, if you double the pressure, the volume will be cut in half. If you triple the pressure, the volume will be cut in third. And it's very accurate and it's very precise every time. Okay? And this is a new thing. They didn't know this was true. So what this is going to lead to is us being able to measure the amount of gas we have. We have to know what the pressure is, or we won't be able. That's one of the factors, remember, that's going to make it able to measure gases. And so this is where we start. Okay, so let's look at our little paper here. And this is called Boyles Law. Now, I really want you to write down the givens. The hardest part, it's not the hardest part, but the main part of this is being able to identify what they are. This will work for everything in life. If you have a problem you need to solve, get what you know down first. Then how are you going to solve it next, and then solve it. So be orderly. Do it in a pattern. Remember, we call that the guess method. Use your givens, unknown, what equations, substitute in numbers, and then solve. Guess. All right. We're going to use a condensed guess method, though. I'm going to use that nice little indigo color that I like so much. And it says right here, a gas occupies 12.3 liters of pressure. 12.3 liters of pressure at 40 mmHgs. So these two things are a pair. They go together. Does it really matter if we call it P1, V1, P2, V2, which one it is? No. It doesn't matter which one you call it as long as you have your pairs with your other pairs, right? Now, because it's listed first, I'm going to call it P1 and V1, but that's up to you. So where I have P1, that's the 40 mmHgs, millimeters of mercury. Right? And the gas occupies 12.3 liters. So volume 1, 12.3 liters. So you have to have your pairs together. You have to have your groupings. Okay, what is the volume? What is the volume? That sounds like an unknown to me. When the pressure's increased to 60 mmHgs. Now, I like to do a little brain check here. Pressure went up, volume's going to go down, right? That's called an inverse relationship. One goes up, one goes down. They're inverses. Okay, let's put this in. Now, there's all different ways to do your algebra. Some people like to put the numbers in first. Some people like to put the numbers in, then do the algebra. Some people like to do the algebra and then put the numbers in. Some people like to put the numbers in and then just do the algebra in the calculator, right? I don't care which way you do it. I do need to see the equation, though, in the right order. So we have our equation written up there. So we have P1 V1 equals P2 V2. I'm going to use the old, heck, I'll do all three. All right, here we go. Again, if you know these methods, fast forward after the first one, I guess. So the first one I'm going to do is the algebra first, okay? So I have P1 V1 equals P2 V2, right? And I'm trying to solve for V2. Now, I know you guys can't do this on yours, but what do you do when you're trying to solve, when you have two things on opposite sides of the equal sign? Well, if they're on top of the fraction, and both of these are on top of the fraction, right? Really, and we don't usually draw that fraction line like that all the time, but in this case, it might help you. I don't know. Okay, right. So if it's on top, when you cross the equal sign, you go to the bottom. When it's on the bottom, you go to the top. That's it. You like little crisscross thing. I cross cancel it. No, they call it cross multiplying. Cross multiplying. Okay, so here we go. So we're trying to get V2 by itself. So what do we do to get V2 by itself? We take P2, and we move it down here. That's it. That is algebra. That's all algebra is. Well, not all algebra is, but enough for us in this chapter, right? Now we have that. Now let's just solve it the way we want to do it. So let's go. P1 is 40. You already have your labels written down in your given. Now write your labels in your given so that way you make sure that they're in the right spot. After that, it gets a little sloppy. You can just put your numbers in. That's fine. And then we'll know what label it is by what it is. So we have 40 times 12.3 divided by P2, which is 60, equals whatever V2 is going to be. Into your old calculator, right? Just do like we did in factor label. If it's on the top, multiply. If it's on the bottom, divide. So I'm going to push in 40 times 12.3 divided by 60. I don't need parentheses if I do it that way. And I get 8.2, and that was going to be in liters. And as I said in the very beginning, if the pressure goes up, the volume goes down, and it did. So that's a good sign. All right? Gas laws. All right? That is Boyle's Law. Now, there's going to be variations of that on this paper that I have out for you. There is a paper today. Let me check my time. Whew, yeah. So there is a paper today. I'm sorry that takes so long to talk about the little things. But these problems aren't too bad. I will have another sheet. They're going to be all Boyle's Laws. Just go along and do it just like I did there. And you should be okay. All right? If there's any weird little things, I'll have a little video to help you get through it. All right. Hey, thanks a lot.